Imagine this, a place that looks like Mars. Red rocks, endless horizons, a thin, hard sky. But here, every sunrise still belongs to Earth. In these remote deserts and volcanic slopes, teams of scientists and volunteers live sealed away from the world. They walk in mock spacesuits, test fragile life support systems, and live as if the next breath truly depended on it. This isn't science fiction. This is a rehearsal for survival. A mission to Mars isn't just a flight, it's a test of everything we are. Our bodies, our machines, our ability to stay sane when the nearest friend is 100 million miles away. The journey itself could take years. The surface? Unforgiving. So before we go, we practice, here on Earth, in what scientists call analog missions. These are fully staged rehearsals. Isolation, confinement, limited supplies, even the delay in communication with Earth. Every detail designed to feel just a little too real. Analog stations come in all forms. Desert outposts in Utah, domes on Hawaiian volcanoes, even sealed ecosystems under glass. Each one asks a different question. How does isolation change the human mind? Can small, mixed crews keep teamwork alive under stress? Can plants really feed a crew for years without resupply? The answers aren't theoretical. They come from the field, from people living the simulation right now. Some analogs push the limits of isolation. Back in 2010, the Mars 500 project sealed 6 volunteers inside a mock spacecraft in Moscow. 520 days. No sunlight, no fresh air, just a small crew, a clock, and the mission. Researchers tracked everything: sleep, mood, memory, and tension. What they found shaped how we think about long-duration spaceflight today. It turns out the human mind is as delicate as the systems that keep us breathing. Others test what it's like to live on Mars. High on Mauna Loa in Hawaii, the HIC's habitat places its crew inside a white dome for months. They wear mock EVA suits, explore the slopes as if they were on the Red Planet, and live with delayed messages, sometimes waiting 20 minutes for mission control to reply. And then there's the Mars Desert Research Station in Utah. Red soil, dry wind, total exposure. Crews there practice geology, grow food in small greenhouses, and manage water like it's gold. Every mistake is a lesson in scarcity. Even the famous Biosphere 2 project, the glass structure in Arizona, taught us something humbling. It proved that closed ecosystems are brutally hard to balance. Oxygen dropped, crops failed, and tiny chemical imbalances rippled through the system. It was a reminder, life support isn't a gadget, it's a symphony, and every note has to stay in tune. Life inside a Mars simulation is deliberate. Every minute is accounted for, not because someone's watching, but because time itself becomes part of the experiment. Each crew keeps a strict daily schedule designed to protect sleep, performance, and morale. A typical day mixes research, repairs, exercise, and shared meals. Without rhythm, everything unravels. Morning starts early. The hum of the fans is their sunrise. Then, breakfast. Freeze-dried oats, instant coffee, and a checklist waiting on the table. Throughout the day, the crew runs field tests, logs samples, checks power systems, and tries not to forget that this is still Earth, even if it doesn't feel like it. Sleep cycles are carefully managed. Light panels mimic sunrise and sunset to keep circadian rhythms stable. Because when day and night blur together, so does your sense of self. Exercise? Non-negotiable. On Mars, your muscles and heart weaken fast. Even here on Earth, the body starts to forget gravity's pull. So they run, they lift, they cycle in place under fluorescent light. Food's mostly prepackaged, or, if they're lucky, a handful of greenhouse greens. Cooking becomes therapy, a ritual that turns science into something human again. Some nights they even schedule movie nights, just to feel normal. A little laughter goes a long way when your world fits inside a metal dome. Now imagine talking to someone and waiting 20 minutes for a reply. That's life on Mars. And here on Earth, analog missions like HICs simulate that exact delay. When the crew sends a message to mission control, it doesn't come back right away. There's no real-time help, no quick advice, no comforting voice saying, "Copy that, we're on it." They learn to think and act alone. This forced delay builds autonomy. It teaches a crew to trust their training, to make decisions fast, and to fix problems without waiting for permission. Because out there, the commander won't ask Earth what to do. He'll act first, then report later. In isolation, patterns always emerge. The first weeks feel fresh, a mix of excitement and curiosity. Then comes the slump, the middle stretch where time feels heavy and the walls close in. And finally, the countdown, the steady resolve to finish what they started. Researchers saw this in Mars 500, in HICs, and even smaller missions. Mood swings, disrupted sleep, and moments of quiet frustration. But here's what matters most. It's not the absence of stress that defines success. It's how you deal with it. The best crews, they build rituals. Shared meals, small celebrations, private reflection time. They respect boundaries because privacy becomes oxygen. When you live with the same 4 people for 8 months straight, even silence becomes sacred. Conflict happens. It always does. But good leadership, empathy, and humor, humor, can turn tension into trust. Scientists now track everything: heart rate, tone of voice, even microfacial expressions. Each data point helps design the kind of teams that could actually survive a real mission. And they've learned something simple, yet powerful. A strong crew isn't one without problems. It's one that knows how to solve them together. Beneath the daily routines lies the real backbone of survival, the habitat itself. Even here on Earth, keeping a sealed base running 24/7 is no small thing. Every watt of power, every drop of water, every breath of air has to be managed like treasure. Solar arrays stretch across the sand, feeding battery banks that hum quietly through the night. Water is filtered, recycled, and filtered again. Nothing is wasted. Nothing can be. Inside the greenhouse, plants aren't just food, they're air recyclers, humidity stabilizers, even emotional anchors. You can't overstate the comfort of a living green leaf when the rest of your world is dust and plastic. These analog habitats are laboratories for resilience. Every filter, every circuit, every failure teaches engineers what might go wrong on Mars and how to fix it when it does. Because when something breaks up there, you don't call maintenance. You are maintenance. In 2023, 4 volunteers stepped into a brand new chapter of this story, a 3D printed habitat in Houston, Texas, called CHAPEA. It stands for Crew Health and Performance Exploration Analog, a name as technical as the place is surreal. For 1 full year, those 4 people live sealed inside, cut off from fresh air and sunlight. Every gram of food, every drop of water, every experiment is logged and rationed, as if they were really 225 million kilometers from home. The habitat itself was printed by a giant robotic arm using a soil mix that mimics Martian regolith. It's about 1,700 square feet. Small, but efficient. Private sleeping pods, a galley, a treadmill, hydroponic racks glowing with red LEDs, and a small medical bay. Step outside that dome and you're in a sandbox that simulates the Martian surface. Crew members there perform virtual EVAs, wearing motion capture suits while their movements are tracked in real time. It's a fusion of simulation and science fiction, except it's all too real.
CHAPEA isn't just about living in a box. It's about learning how to think without Earth's constant hand-holding. On Mars, help would take 22 minutes just to arrive, so when something goes wrong, the crew must respond first and explain later. Here, autonomy isn't a buzzword, it's a survival skill.
Software monitors greenhouse humidity. 3D printers fabricate spare parts. AI tools help plan each day, sorting maintenance tasks, predicting system faults before they happen. Even something as simple as patching a leak becomes a mini rehearsal for the real planet. These analog missions, scattered across Earth's deserts and volcanic slopes, are slowly building the blueprint for living off it. After decades of these experiments, patterns begin to emerge. In Mars 500, scientists tracked psychological health over 520 days, and what they found was fascinating. The curve followed a rhythm: excitement at the start, then monotony, mild depression, and finally, recovery and resilience near the end. Even the body joined in. Sleep cycles drifted, heart rate variability dropped, stress hormones rose and fell like tides. At HICs, researchers saw the same thing, that so-called third-quarter phenomenon. After decades of these experiments, patterns begin to emerge. In Mars 500, scientists tracked psychological health over 520 days, and what they found was fascinating. The curve followed a rhythm: excitement at the start, then monotony, mild depression, and finally, recovery and resilience near the end. Even the body joined in. Sleep cycles drifted, heart rate variability dropped, stress hormones rose and fell like tides. At HICs, researchers saw the same thing, that so-called third-quarter phenomenon, where crews dip in morale mid-mission, then bounce back once routine settles in. And the data pointed to one clear truth: team composition matters more than personality tests. Why? Because diversity forces creative problem-solving. When communication breaks down, isolation grows. But humor and shared rituals pull people back together.
When crews celebrated birthdays or cooked themed dinners, their stress hormones literally dropped. Turns out the secret to surviving Mars might just be friendship and food.
7 o'clock. The lights rise slowly. Not sunlight, but LEDs mimicking dawn. The crew stirs, stretching in narrow bunks, the air filled with the steady hum of recycled oxygen. 8 o'clock. Breakfast. Instant oatmeal, freeze-dried fruit, strong coffee. It's not fancy, but it's fuel, and routine is its own kind of comfort. By 9, systems checks begin. CO2 scrubbers, oxygen levels, water recycler flow rate. Every click of a gauge means one more breath, one more day. By 10:30, preparation for EVA. Medical checks, suiting up, pre-breathing oxygen. Each step deliberate, methodical, because mistakes, even here, teach the cost of haste. At 11, 2 crew members step through the airlock into the red dust field outside. They collect geological samples, log data, snap photos for mission control. Their voices crackle over delayed radio, every word echoing across 20 simulated minutes of space. By 13, they're back. Lunch. Debrief. Laughter. The good kind.
born of fatigue and pride. Afternoon brings experiments, seed germination, 3D printing, system repairs. At 1700, exercise rotation. 1830, dinner. At 2000, it's quiet. Each crew member retreats to their cabin, a 2 by 3 meter box, their only private world. 2200, lights out. The hum of fans replaces silence. Outside, the desert night looks almost like Mars. And maybe that's the point. In confinement, the biggest landscape isn't out there, it's inside. Crews talk about strange dreams, open skies, the smell of rain, even traffic noise from cities they used to hate. Psychologists call it Earth withdrawal. To fight it, they test virtual reality headsets, projected nature scenes, and recorded sounds of forests. But what truly helps is meaning. Knowing that their isolation isn't wasted. That what they're learning here might one day keep someone alive out there. When you realize that every note you write could change how we live on Mars, it's easier to wake up in a box with no sunrise. Maybe that's the secret. Purpose. Without it, even a dome full of oxygen feels empty. With it, even a sealed room can feel like the edge of discovery.
Long missions demand self-sufficiency. Inside CHAPEA and high seas, crews grow dwarf tomatoes, lettuce, and microgreens, not just to eat, but to breathe. Every kilogram of fresh produce cuts down on supplies they'd otherwise ship across millions of miles.
NASA scientists discovered something else too. Tending plants lowers stress hormones. Cortisol drops just from touching soil, even simulated soil. It's a small reminder of Earth, glowing under red LEDs. But complete ecological balance, that's still the dream. Biosphere 2 proved how fragile that balance really is. Oxygen levels crashed by 40% within months. So for now, future habitats will mix biology with chemistry, part living systems, part machine, until we finally learn how to make life sustainable off-world.
Every analog mission uncovers new pain points: dust, thermal control, radiation, data overload. Regolith dust is electrically charged. It clings to everything, grinding into joints and seals. Even short EVAs clog filters and scar equipment. Solar panels have to survive dust storms that can swallow sunlight for weeks. Engineers test aerogel insulation, inflatable modules, and pressurized rovers. Solutions that sound like science fiction until they're not. This is the engineering rehearsal for the real performance, the one that'll take place millions of kilometers from home. In these deserts and domes, humanity practices for its next giant step. Every analog habitat is a promise that one day we'll cross the void not as dreamers, but as builders. Inside every simulated sky, we learn what it means to depend on one another. We learn how fragile our systems are, and how much more fragile we are. When the first human finally stands on the Martian surface and looks back toward Earth, they'll be standing on the shoulders of those who lived the experiment here, in the silence of Earth's most unforgiving places. Because before we reach Mars, we have to learn how to live like it's already here.